This is the first sort of session that I'm going to conduct, so there can be mistakes. So please make sure if you find any mistake in the video, please comment down, or you can mail me. I will add my mail ID in the description box. Okay, so in the next 4 or 5 videos that I'm going to upload, I will discuss about group action, some application of group actions to deduce the conjugacy class equations, and silo theorems. And we will discuss some examples, like some applications of silo theorems. And then I will move on to other topics of ring or field that we'll see. Okay, so in the first video, I'm not going to discuss anything regarding to group actions and all. So I'm just going to tell you what the like how will you proceed in the next 4 to 5 videos. So it will just be a short video of 5 to 10 minutes, I guess. So the topic that I'm going to be starting with is group actions. I'm not going to any details of this. I will start from the next videos. I'm just going to give a brief uh, understanding of what the subject is. So for that, the prerequisites are very minimal actually. You need to know what is group, of course. In algebra, you need to know what is a group. Of course, then you need subgroup also. You also need to know what is a homomorphism between two groups, the isomorphism, and isomorphism theorems, and also normal subgroup. Sorry, my handwriting is not very good, so just bear with me. These are the prerequisites from abstract algebra part. From linear algebra part, because in some examples of group actions, we need to know what are orthonormal or say orthogonal matrices, the basic basis dimension stuff, the linear transformations, and what are inner products. Not very details, just some brief understanding of what are inner products. Okay, so the path will be like, first I will talk about group actions in the first 2 lectures. Then in the next 2 sessions, I will describe some examples, deduce some formulas that I hope all of you have seen, but in a different context, or you have seen a different proof. This will be a lot simpler proof using group actions. For example, the Lagrange's theorem and another few countability like statements like this order of this is this. And now there will be few examples. Then you need uh, it's also good to give some other perspective about group actions, not regarding only groups. So I will move away to what I call representation theory, that is just action of a group on a vector space. Then I will detail some 1 or 2 theorems, basic theorems, like the theorems that you know when you are studying representation theory, the very fundamental ones. first two or three, not very details. Then I will come back again to the group theory part. There I'm going to be talking about the class equation and silo theorems. Okay, then it will take a few classes, like it will take at least two classes for me to deduce class equation and also silo theorems. And then we'll see how to proceed. Like then we can discuss some application of silo theorems. We can talk simplicity of some groups. Like we can also say classify groups of some certain order using silo theorems, and then if required we need to establish some more machinery, like say what are called semi-direct products, to classify some not very large order but some certain small order groups, like group of order 12 and 21 and all. Then we will see an example of a simple group, that is a group having no non-trivial normal subgroups. That is, I mean, the no, only two normal subgroups are the identity and the entire group. So those things will come later. First, I will start with the group actions and all. Then we will move to representation theory for a bit, for one lecture maybe. And then I will again come back to group theory to discuss, say, class equations and silo theorem. So all in all, it may take say 2 plus 1 3. It will take uh, 5 lectures, I guess. It will not take anything more than 5 lectures. And I will try to upload it on regular basis. Like regular basis means once in a week. And so I guess in the by the end of August I will be able to complete this. So yeah, that's it for this video.